Hi, Hickory Creek 7th graders. This is Mrs. DeHaan, and today I teach math on Team 7A, for those of you who do not know me. Today we're going to talk about a little bit more about triangles. So earlier this week, you learned about the triangle inequality theorem that Ms. Clutchurch explained to you. Now, today we're going to build on relationships and theorems related to triangles, and we're going to learn about a new triangle theorem called the triangle sum theorem. So what I want you to do before we get into that is think back to 6th grade. So in 6th grade, maybe even before that, you learned a little bit about triangles and you learned how to classify triangles. So we can classify triangles according to their angles and according to their sides. When you classify triangles according to their angles, we use terms like obtuse, right, and acute. Now we're going to kind of build on the angles of a triangle and the relationship that they have and how we can use that to solve problems by talking about a new theorem called the triangle sum theorem. So how I'm going to show you, to show you how and why this theorem works is easier than just reading a definition about it. It's a nice visual. I'm going to share a screen with you from our textbook, the old version of our textbook, because it's a nice example. So if we look here at problem number 1, it talks about the interior angles of a triangle. So the word interior just means the angles that are on the inside, okay? And it says that, or it asks us to draw any triangle on a piece of paper. Tear off the triangle's 3 angles, arrange the angles so that they are adjacent, okay? Remember, adjacent, we learned last week, means that the angles are next to each other. So we're going to arrange them kind of like a puzzle and put all the angles after we tear them off and put them next to each other. And then they say, what do you notice? So when we're in school, what I usually do is I have a triangle that is on construction paper, or I give each one of you a triangle that's on construction paper, and we actually do this, or I project it on an Elmo. I don't have that here. So what I'm going to do, some of you may think this is a little funny, I'm being resourceful. I have a cookie sheet here with some magnets. Okay, it was the best I could do. So if we look here, I have this blue triangle and I labeled each one of the angles just with a number in the corner. Angle 1, angle 2, and angle 3. So we're going to use this and do exactly what that problem asked us to do. So let's imagine that, let me get comfortable here with my cookie sheet. If I were to cut these corners off, okay, and if I take those corners or the angles of that triangle and I make them adjacent to each other like they asked us to do, so I'm going to move that out of the way. Here, I'm going to rotate them a little bit so that the numbers are all on the bottom, right? Because the corners here with the numbers were the actual corners of the triangle. And they said, arrange them so that they're all adjacent. So we're going to put these like a puzzle as close to each other as possible. So here we have, excuse me, we have the 3 angles of the triangle all placed next to each other. I purposely left a little gap just so you can see. And what do you notice? Okay, so hopefully what you notice is, and I'll use my pen as a guide there, that those 3 angles of the triangle, when you put them together, they form a straight line. And what do we know about a straight line? We know that straight lines have a measure of 180 degrees. So what is that triangle sum theorem that this demonstrates? The triangle sum theorem states that the sum of 3 angles of any triangle will have a sum of 180 degrees. So basically, very simply, when you add up the 3 angles of any triangle, it will always be 180. And again, if you cut them off, which we won't always do, but if you were to do that, they would always form a straight line, which is also 180 degrees. Okay, so hopefully this visual sticks with you and helps you remember straight line, 180, 3 angles of a triangle, 180 degrees. Okay, so let's look, put the cookie sheet away. I'm going to share a screen with you and show you the types of problems we might see. So here we have some problems from our skills practice. Okay, let me get, there we go. I'm getting the annotate on there and making sure I can write. Okay, so if I were to look, let's look at number 5. Oh, look at me already erasing. Actually, before I do that, I want to kind of make this a little bit bigger. Okay, better. Okay, so if I look at number 5, down in the lower corner here, I have angle W is 60, angle X is 60, and they want us to find what is the measure of angle Y. So what I would do here is, I'm using my pen, so I have to move a little closer. I would add the two angle measurements that are given, 60 plus 60 equals 120, okay? And then, since I know that the three angles of a triangle equal 180, I can do 180 minus 120, and I see that angle Y is also 60 degrees. And so I can write 60 degrees right down here. And we can see that the triangle X, W, Y, which is number 5 down there, is an equilateral triangle because the three angle measurements are the same, which would mean that the sides would also be the same. So let's look at another example. Erase all this. Okay. Now, I'm going to fix this. I want a little bit thicker of a marker. Okay, let's look at number 6. Number 6, they give us the measure of angle T and the measure of angle V. So again, if I were to add those, 110 plus 35, I get 145. Okay, so 180 minus 145 gives us 35 degrees. Okay, so that means, and I went a little bit too thick on my drawing. I guess I can't find a happy medium here. Would also be 35 degrees. And that makes sense. I could double check that and say, okay, well, let's add up the three angles. 35 plus 35 is 70. 70 plus 110 is 180. So that's a good way. You should always check and make sure you did those correct. Add up the three angles after you think you found the missing angle, and they should always have a sum of 180 degrees. Okay, now that theorem would work on any one of these angles. So if you look up at the other two angles, we have an obtuse angle and a right angle. They would also equal 180 degrees if you were to add up the three sides. When they give you two sides and the third side is missing, you add up the two that are given and you can subtract that from 180. So let's look real quick at one last thing. Okay. Go back to annotate. I want to erase this. Once you find the sides, the angles of a triangle, you can also put the sides in order from shortest to longest, or smallest measure to longest measure. So if I look at number 4, okay, number 4, I might as well go ahead and solve that. Let me annotate again. Number 4, if I take 90 plus 32, I get 122. Okay, and then I can do 180 minus 122, and I get 58. So I know that this angle G has a measure of 58 degrees. Now, once you have the three angle measures provided, the opposite sides, so by opposite side, I mean the side that is across from the angle that I'm talking about, that's how you determine which one is the longest. So the largest angle, so for number 4, the largest angle would be angle F, because it has the biggest measure, the largest measure, 90 degrees. That means that the angle across from it, which would be GE would be the longest side, okay? The shortest side would be across from the smallest angle. So the 32-degree angle, angle E, is the smallest angle. So the side across from it is the shortest. So if I were to put these sides in order from largest to smallest, the largest angle, or the largest side, would be side GE, and then side FE, and the shortest side is across from the 32, which is GF. Oh, that's a funny looking F. All right, so that is one more thing to learn. Once you find the angle measures, how you can also use the angle measures to determine the side lengths, or at least the order or the longest or the shortest side length of a given triangle. So that's all for today. Let me stop sharing. So hopefully that kind of reviewed a little bit of old triangle concepts and introduced you to the new theorem, the triangle sum theorem. Always remember the demonstration we had here, okay? The angles equal 180 degrees because they would make a straight line. And if you would like some additional resources, check out the links on the HyperDoc that we gave you for the week. And there's some more videos with some more examples if you'd like to find out more relationships or just see more examples. Hope you are all doing well. We miss you very much, and keep working hard. We're really proud of you guys. Take care. Bye.